The following is the video solution from JSDT Solutions. Question 11.1 says, events A and B are mutually exclusive. Okay, so if they're mutually exclusive, then it means that these circles will not intersect. And so what that means is because we don't have an intersection, that probability of A and B is equal to 0. Okay, and then they tell us that the probability of B is twice the probability of A, and the probability of A or B is 0.57. Okay, so let's go ahead and find the probability of B using this information that we have. So because they've given us the probability of A or B, we can use this rule. So the probability of A or B, and to find the probability of A or B, we say the probability of A plus the probability of B minus the intersection of A and B, which we know is 0 since they are mutually exclusive. So the probability of A or B, that is 0.57, is equal to the probability of A plus the probability of B, which they told us was 2 times the probability of A. So you see that this equation will solve for the probability of A, but then we can use that to solve for the probability of B. Okay, so this is equal to, if you say probability of A plus twice the probability of A, it's just like saying x plus 2x. So that is 3 probability of A. And that's 0.57. Then we can just divide both hand sides of this equation by 3. Therefore, the probability of A is equal to 0.19. Okay, so 0.19. And now we can find the probability of B. So you see how they told us the probability of B is 2 times the probability of A, and that's how we'll find that. So probability of B equals 2 times probability of A. So it's just 2 times 0.19. Okay, so 2 times 0.19, and that gives us, okay, that is like 2 times 20, which is 40, and then minus 2. So, okay, so this will finally be equal to 0.38, and that is our answer. Moving on to the next question. Question 11.2 says, a box of 40 calculators is sent to a store by a supplier. The owner of the store is not aware that 5 of the calculators are defective. 2 calculators are selected at random from the box, the first one not being replaced before the second one is selected. Okay, so we're just not replacing. And then 11.2.1 says, what is the probability that the first calculator chosen is not defective? Okay, it's the first calculator chosen. If we know that there is a box with 40 calculators, 5 are defective, then it means that 35 are not defective. And so the probability that when these calculators are in the box that you're going to pick one that is not defective would just be 35 out of the total 40 calculators we have. Okay, so this is just 35 over 40, which these are both divisible by 5. 35 divided by 5 is 7, and 40 divided by 5 is 8. And that is our answer. Moving on to the next question. Question 11.2.2 says, what is the probability that if 2 calculators are selected, one calculator is defective and the other is not? Okay, so we can actually just draw this tree diagram because we are selecting calculators here. So in this tree diagram, we have calculators that are defective and the ones that are not defective. We know that there are only 5 that are defective, so out of the 40, and then 35 out of 40 is not. So in the first pick, when you're picking out a calculator, the probability that it will be defective is just 5 over 40, and the not is 35 over 40. Then remember that these calculators will not be replaced. Okay, they won't be put back as they said in the first part of this question. So it means that the probability that you're going to pick out a defective calculator, if the first calculator that was picked was defective, it means that there will be one less defective one, okay, over a total of how many calculators? Well, one calculator was picked out and it wasn't put back, so over 39. And then the probability that we will pick out a calculator that is not defective. Remember, we're saying if a defective was picked out first. So the ones that were not defective has not been picked out. So there's still 35 of them out of a total of 39 calculators because a defective was picked out. Okay, same thing over here. The second pick would work like this. It could work like this. If it was a non-defective calculator that was picked, then what is the probability that a defective calculator would be picked in the second pick? So it's a non-defective that was picked. Defective was not picked in this situation, okay? So it means that there would still be 5 defective calculators, but we know that a non-defective has been picked, meaning there are 39 calculators left in the box. And then what is the probability that we would pick a non-defective in the second pick, given that a non-defective calculator was picked? Okay, if a non-defective calculator was picked, it means now you have 34 non-defectives over 39 calculators because one has been picked. So this is what it's going to look like. And the question specifically just wants us to find the probability that the calculators picked, okay, if we pick in 2 calculators, one calculator is defective and the other is not. So here's how this is going to work, okay, defective and not. We're just going to have to look at these outcomes. So all the outcomes we could get in these 2 picks. So here we could get defective and defective, okay? And then you could also get a situation where the first pick you got a defective calculator and then in the second you got a non-defective. So defective and non-defective. You see that this is one of the cases that they're referring to, okay? Because one is defective, the other is not. And here's another outcome that we can have. We could pick, in the first pick, we could pick a non-defective calculator. And then in the second pick, we pick a defective. And the last outcome we'll have is we pick a non-defective calculator and a non-defective in the second pick. Okay, so these are all the outcomes that we can get, and we need to just look for the one that has defective and non. You see that there are 2 outcomes that we have like that, defective and non-defective and defective. So we're just going to have to take that. So here's how we'll find that. We're taking the probability that we're going to pick out a defective in the first, okay, and a non-defective in the second. So it's just going to be, so we're taking that and we're taking this. So we're just saying we could take this or this, meaning we're going to add these values because these 2 cases work. Okay, so then the probability that it will be a non-defective at first and the second one will be defective. And that's all we're going to add together. So let's look at the outcomes. It's defective and non-defective. So that is the 5 over 40 multiplied by 35 over 39. And then we add that to non-defective pick first. Okay, we picked out a non-defective calculator. So that is 35 over 40 multiplied by and defective in the second pick. So that is 5 over 39. And all we'll have to do is calculate this. And that is our answer. And our answer is 35 over 156. And I'll just leave it as a fraction. Okay, so that is it for question 11.2.2. Question 11.2.3 says, what is the probability that if 2 calculators are selected, both are defective? So we're just looking for defective and defective. So do we see that in our outcomes? Yes, we do. It's this first one, okay? Probability of selecting a defective in the first and a defective in the second pick. So that's going to be 5 over 40 multiplied by 4 over 39 because they're happening together, so we multiply. Okay, so 5 over 40 multiplied by 4 over 39. And let's just find this answer. Okay, we can just calculate this. So 4 divided by 4 is 1. 40 divided by 4 is 10. 5 over 10. Okay, so 5 divided by 5 is 1. 10 divided by 5 is 2. So that's 1 over 2 times 1 over 39, which is 1 over 39 times 2. That's 80 minus 2, which is 78. Okay, and that's our answer. 1 over 78. But you're probably not going to want to cancel these things. Just do it with a pencil and then leave that so they can see your calculation. Okay, moving on to the next question. Question 11.3 says, 4 different economics books and 3 different life science books are required to be placed on a shelf. So there are 4 economics books and 3 life science books. And 11.3.1 says, if you decide to place any book in any position, in how many different ways can you arrange the books on the shelf? Okay, so just remember these are different books. They're not exactly the same. So we're just looking at it like this. There are 1, 2, 3, 4, 5, 6, 7 positions. Okay, now before the first book is placed down, right, when we're deciding on where to place this, how many different places could it sit in? It could sit in the first place, the second, third, fourth, fifth, sixth, seventh. Okay, so this first book has 7 different options to be placed in. Then once the first book is placed down, the second book would have 1, 2, 3, and there are 6 spots remaining, meaning it can be placed in any of these 6 spots. That's 6 choices. Then once that is placed down, the next book would have 5 different choices. Then the next 4, the next 3, 2, and 1. Okay, so these are the options, and we're going to multiply them. And that gives us 7 factorial. Okay, so you can write it like that, or you could just say 7 factorial, and then on your calculator, say 7 factorial. Okay, it's that button, and this is 5,040 different ways. Okay, they just said in how many ways, so you can just tell them it's 5,040 ways. Moving on to the next question. Question 11.3.2 says, if 2 particular books must be placed next to each other, in how many different ways can you arrange the books on the shelf? Okay, so 2 particular books. They don't say which books. So let's just see it like if we had to just group 2 random books together and they have to be placed next to each other, here's how we can look at this. So we're just going to group 2 books together. Okay, now in how many ways can they be placed on the shelf if these 2 must be together? Okay, so looking at them, like these 2 books on their own, right? They can be placed as, remember that they are 2 different books. So they don't have to be placed in this order where this economics book is first. It could be this economics book first. So it could be placed like this, where this one is in the first position and the second. Or it could be in a way where this one is in the first position and that one is in the second. Okay. So on its own, it has 2 different ways or options to be placed at. If you like, you can say 2 factorial, which is what we usually do. And then now remember that the books can be placed anywhere. They don't have to be placed here. Okay. So now that we have that, now it's kind of like looking at them as if they are groups of their own. This is one group. This is another group of its own, another group, and those are groups of their own. So now we're looking at the placement within these groups. So these 2, they don't have to be in front necessarily. They could be in this position. Okay, they could be here, they could be here, and here, and here. So looking at the group positions, you see that there are 1, 2, 3, 4, 5, 6 positions there. So this group has 6 different options it could be placed in. So we'll look at that as 6 multiplied by, and then once placed down, the next book or the next group, okay, of its own, it's going to have 5 different options to be placed at. It can be placed here, 2, 3, 4, 5. Okay. And then once it's placed down, the next book would have 4 different places to be placed in because they're not restricted to just these positions. They can move around. So that would have 4 different positions, and then the next one will have 3, and then 2, and then 1. So altogether, this gives us 6 factorial. Okay, and that's how we would find this. 2 factorial times 6 factorial. And that gives us 1,440 ways. Okay, now just check if they asked for the probability. No, they didn't. They just said in how many different ways. So that is our answer. And moving on to the next question. Then question 11.3.3 says, if all the economics textbooks must be placed next to one another and all the life sciences textbook must be placed next to one another, in how many different ways can you arrange the books on the shelf? Okay, so in this case, we are grouping all of these books. Okay, the economics are together, life science are together. So let's group them. It means that this is a group and this is a group. Okay, so let's look at the ways they can be placed on this shelf. So with the economics textbooks as a group, as this little group of their own here, remember that these 4 books are different books, okay? They're not the same. So it means that as they are like this, the total ways they can be placed in would be 4 factorial. And the reason why is because the first book, again, has how many different places in this little group to be placed in? It could be put here first, okay? It could be put in the second position, the third, or the fourth, okay? And then once placed down, then the second book would have how many different options? That's 1, 2, 3. And then once placed down, the third book has 1, 2, and once placed down, the last book just has 1. So that's why it's 4 factorial. 4 times 3 times 2 times 1. And likewise with this, that would also work like that. Okay, first book has 3 different positions, and then 2 different, and then 1. So that's 3 factorial. Okay, so now that it looks like this, we can look at them as a group. This first group, when we are placing this down on the shelf, right, we have 2 positions, 2 group positions. They could either be here in front of the life science textbooks, or they could be in place of the life science textbooks. So that means the life science textbooks will come first. So that means that group has 2 choices, okay? Then once this group is placed down, then this next group, we're looking at these groups as if they were individual books. This next one has only 1 choice to be placed in. So that will be times 1. So you see how that's 2 factorial, 2 times 1. So the answer will be 4 factorial multiplied by 3 factorial multiplied by 2 factorial. And let's get our answer. And this is 288 ways. Okay, so we can just tell them that it's 288, and this is just in how many different ways. It's not the probability they're asking for. So that is our answer. And that is it for question 11.